In the first block of Bitcoin, Satoshi embedded a newspaper headline. In fact, so arguably, Bitcoin was used for data storage even before it was used for value. We built Arweave as a kind of, at the time we called it a sister net. That's a pretty strange term. But basically like a parallel form of the web. And from this, the idea of the permweb was born, which is essentially, trustless web applications, imbuing all of the normal services that we use in cyberspace with the properties of blockchains. AO, put simply, is a hyperparallel computer. It takes that same idea of people storing blockchain information inside Arweave, but then scales it.
Hello, everyone, and welcome back to the Unleashing DePIN Podcast. My name is Tyler. I am your host, and I'm very excited for our next guest that we have. We have Sam. He is the founder of Arweave and AO. Quite excited for this conversation that we get to have. But Sam, welcome to the pod. How are you doing?
Doing great. Thanks for having me on.
Absolutely. I'm quite excited to dig into everything that you're building with Arweave. You guys have been really innovating in the space for quite some time. And in addition to that, you've got quite a few new announcements and developments that are happening on the AO side. So I'm quite keen to dive into that. But maybe before we do that, I'd love to learn a little bit more about yourself, how you found yourself building in this space, how you found yourself at Arweave developing what you've been building there, and then we can kick it off.
For sure. Yeah, we got started building Arweave about 8 years ago now, essentially inspired by the idea of making on-chain storage that scales. In the first block of Bitcoin, Satoshi embedded a newspaper headline. In fact, so arguably, Bitcoin was used for data storage even before it was used for value. And that newspaper headline is now replicated in about 100,000 different places around the world at minimum in every Bitcoin that is online and is replicating the blockchain. And so we thought that this was a really exciting idea. It allows you to make a ledger of history that is outside any single person's control and publicly available, held in mutual public trust, if you will. And yeah, that's a really powerful and inspiring idea. And when we got started, we were very concerned about the progression of speech rights on the internet, essentially. And so we thought that one way we could contribute to solving that problem would be if we could make it so that everyone could say whatever they wanted to say and have it be neutrally, transparently replicated around the world. But the problem was scaling. All of the blockchain architectures at the time before Arweave came around just didn't scale on-chain storage. And really, they don't today even, as far as I'm aware. I was watching the new architectures that come out, but really, there's nothing that has arbitrary quantities of data storage in the way that Arweave does. And so we set out on the sort of road to solving that problem. We launched the network, the first version, about 7 years ago now, just coming up to its 7th anniversary of mainnet. And the vision has stayed essentially the same, but expanded slightly. There was this moment where we realized all of the content that's available on Arweave is available via HTTP. So it renders in your browser. The idea was, what's the best way that people can access information in the modern age? The web. And so we built Arweave as a kind of, at the time we called it a sister net. That's a pretty strange term. But basically like a parallel form of the web, where all of the content is imbued with the properties of blockchains. And it turns out that speech acts in the modern world are not just saying something, asserting something to be true, but also publishing code. Essentially, publishing applications. So it's also a form of speech. And it turns out, without changing the system at all, it supported and supports full decentralized web applications to be hosted on top of it. So you can point your browser at any ID in the system, and if it's a web application, it will just render and look and feel like a normal app, except with a giant shared database connecting all of those applications. And from this, the idea of the permweb was born, which is essentially, trustless web applications, imbuing all of the normal services that we use in cyberspace with the properties of blockchains. That's permissionlessness, immutability, verifiability, and trustlessness. And so that's been a really exciting journey, basically helping build out the underpinnings of a new form of cyberspace, we see it as, a way that people can collaborate and work together online or share their ideas that is outside the control of any one party, but looks and feels just like the normal web. And so we got the network launched 7 years ago, and now it's up to about 15 billion pieces of information stored, slightly more now even, which is quite a staggering amount It's about a third of the size of the current index of Google. And Google only indexes like the surface web, they call it, the top level. So there's much, much more growth to go. But still, it's like a kind of meter of where we're at. And yet, the takeoff has been quite incredible. So
that's incredible. It's been a fascinating journey. One of the things that's interesting, somewhat unrelated, was actually last night I was going through an architectural deep dive of why Satoshi chose the Berkeley DB instead of something like SQLite at the time, which is a little bit orthogonal to actually codifying like the chancellor on the brink of bailout in the first Bitcoin block. But one of the things we take for granted in a lot of respects is all of these open web protocols, whether it's HTTP, things like Open Graph through sort of social links and sharing. But how are you, from an architectural standpoint, actually storing all these data? Is there, each data has its own block effectively? Or can you just share from an architectural standpoint a little bit about how Arweave works?
yes, there's so many different places that can go. But the broad principle is that we put data on chain, but instead of having a push mechanism for the data being spread around the system, which enforces a sort of network-wide bottleneck on bandwidth, essentially, which is common across all traditional blockchains. Instead, what we do is we have a pull mechanism. So someone publishes a transaction to the network, they pay for it, and that embeds a Merkle root, so a sort of minified representation of the wider data set underneath it, you could say, of all the different pieces of data, the chunks of information inside the content that they're trying to upload. And then the nodes in the network that want to replicate it, and we have a system of incentives to make sure that happens, and a cryptographic proof system to make sure that people are doing it. Yeah, all the nodes that want the data then just pull it in a way that's similar to BitTorrent. That's the sort of high-level architecture. But in order to make it so that it truly arbitrarily scales, Arweave runs at about 500, 600 new pieces of information published per second.
Wow.
Yeah,
That's staggering.
Yeah, it's not very hypey. A few people outside of the technology-focused people in crypto know about it, but it like is the underpinning for a pretty big part of the wider crypto ecosystem at this point. But how that works, with traditional blockchains, you have this problem of basically avoiding a double spend. And that's the core of why a blockchain is really necessary. There were many experiments. Sounds like if you're getting that deep into how Bitcoin is architectured, you might be aware of them.
I'm a little bit of a Bitcoin history geek personally, so
Nice.
I have a good.
But yes, so there were many different experiments before. None of them required a blockchain, but they all required centralized trust in order to solve this problem. Like you can use cryptographic, exactly, DigiCash, eGold, and so on.
Yeah.
You can use cryptography on its own without a blockchain to have the underpinnings of a digital cash form. But what you can't do is have, a solution to this double spend problem that doesn't enforce a centralized arbiter without something like a blockchain. And the problem when you get to storage is, okay, how do you make it so that without enforcing this like scalability limit, how do you make it so that everyone can upload? And in the case of Arweave, once we got it so that the network itself scaled arbitrarily, like you can fit 2 to the power 256 bytes inside a single Arweave transaction, which is something like 10 to the 60, I believe, or 10 to the 30 times more bytes than there are atoms in the universe. So it's like absurd amount of data. It's really not going to run out. But the problem was, okay, how do you make it so that's per transaction? How do you make it so that each individual user can use all of that capacity? And in order to enable that, we built the system of bundling, which is basically where, okay, so we don't actually care about double spend problems in very small quantities. Like the price to upload something to Arweave can be fractions and fractions of a cent, like 1/100th of a cent for the smallest thing you can upload. What we can do instead is basically have these nodes that will bundle many pieces of data together and then submit it as one. And so you have that double spend protection on the actual commitment of information to the network. Someone pays the network in a way that is relatively in line with a traditional blockchain. But you can pay instead a bundler to put your data next to other people's data, essentially, then commit it and upload it for you in one go. And the net effect for users is they can use all of that capacity. So it really just does scale arbitrarily. And this is only possible because it is permanent information storage, interestingly. If you had different contracts for each individual piece of information that was uploaded, there's no way that this could work. You only get it because everybody's data is neutrally the same. yeah, so from an architectural level, that's broadly what's happening. And then on the nodes themselves, they have a relatively complex system for managing it because it's like a pretty big data set.
Yeah, I would assume that's quite a computational challenge. And then just from my understanding then, if you translate that to maybe Bitcoin style terms, would every piece of data that's stored be like the equivalent of a transaction hash that gets mapped to something that a web browser can pull via an HTTP request? Is that high level how the system's designed, or can you maybe help clarify that?
Yeah, broadly. So it's like every transaction can also have a data field, which is represented just by this Merkle root hash of the data. And that includes the necessary components that we need in order to make proofs later that a miner has actually stored the information. And then, yes, you can access that via HTTP, but also the nodes, particularly the indexing services. And there's a whole nother service built by a different group in our ecosystem called AO that let you run and be paid to operate gateways, which index inside those individual pieces of data as well. That allows you to get this like arbitrarily deep tree of bundles, basically, of information being added. And then you point your browser at it and it just looks and feels like a normal web application.
Very fascinating. So is there kind of a use case for an application where this could replace or offset some of the requirements that they're like for the Wayback Machine, for example, being able to have a chronological history that's actually cryptographically sound? Is that something that you can really do with Arweave here?
Yeah, so actually one of the first things we ever built on top of Arweave, once we didn't even have to change the software, but when we realized that you could upload and use full web applications on top of it, was this thing called Craig, the censorship-resistant Internet Archive Gateway. And basically the idea there was we can upload the torrents that the Internet Archive already made available to Arweave, and then you have an immutable record of the metadata of all the content and a way to access it in a decentralized way, or at least a distributed way using BitTorrent. And yeah, that was like the first thing we built, and we worked with them on that, and that was a pretty exciting project.
That's really exciting.
It turns out it's much, much wider than that. Like when we got started, we knew that what's the mission? It's very simple to say, it's permanent information storage, full stop. But the implications of those three words are like massively outside of the scope that we'd originally envisaged. We thought it would be an archive to start with, but now most of the uses of it actually relate to the sort of additional benefits that you get from the information being permanent that just aren't obvious on the surface. And that's basically that the information itself becomes trustless and neutral. So the information is, available to all people, and it's not revocable from the point of view of the person that uploaded it. It's like the data is held in the public commons, essentially.
Yeah.
And so people use it for example, like replicating large other blockchains. Things like, there's this whole project called Kive, and they replicate, I think, 20 pretty big name blockchains, because interestingly, most other blockchains don't have incentives for the replication of the data set itself. And the more scalable the blockchain becomes, the bigger a problem that becomes, because they just add more transactions.
Sure.
And so the burden of maintaining their old ledgers larger. And through these mechanisms, they can use Arweave to replicate all of the transactions, all of the blocks, and have incentives for it to be stored over time. So that's just like one use case of the system that really wasn't obvious when we got started.
That's really interesting. Honestly, it's funny you say that, because one of the ideas that I always had around like Bitcoin nodes was some function of this where instead of needing to maintain the entire ledger history, you could have maybe a portion of it, but you're able to store all the old transaction, all the different blocks like in something like this, and maybe use, I don't know, like a Merkle root or whatever to like point back. That always seemed like a way to maybe lower the barrier of entry for node operators in Bitcoin. It sounds like that's actually happening though with various projects.
Yeah, totally. And if you go to kive.network, you can see all the different projects that are doing this. It's a bunch. It's most of the big names of the chains out there, I think, actually, at this point.
Wow, that's super interesting. What else is being built on top of Arweave? I know that there was the NFT mania that I'm sure drove quite a bit of adoption. I believe you're also storing some Facebook data, if I'm not mistaken.
Yeah, when Facebook were making, or it was Instagram, but Meta, when they were making NFTs, they were uploading all of them to Arweave. And that was another downstream effect of permanent information storage that just wasn't like clear at the start. Is that, okay, so if you have digital content that you're trying to monetize or basically make tradable one way or another, yeah, like you don't want that content to disappear. It's quite interesting. We actually have this archive now. It's become an archive. It was like a, just say, actively used data set. It still is some of them, but mostly archival now. Yeah, of like Tulip Mania.
Yeah.
Imagine you could go back in time to Amsterdam during the time of the Tulip Mania. That's actually what you can do now on Arweave. But yeah, if you have a piece of digital content that you're going to sell to someone, you don't want the original seller to be permanently on the hook to make sure that data is replicated. Right. Nor does the buyer want to have to think about upkeep. So why not just put it on Arweave? It's very cheap. It's less than a cent per megabyte generally to store the content, and then it's just available permanently, publicly, indefinitely into the future.
That's really fascinating. And I think that was certainly an overlooked aspect to that NFT mania at some point. People are like, yeah, you have the 721 on Ethereum, whatever it may be. But if they're hosting that image on AWS somewhere, which is potentially what they were doing, and they stop paying their server bill, then you're out of luck for the original content, which is a challenge or a problem if you're expecting these things to be held for some long period of time.
It's a huge problem.
Yeah. So one of the things I'm also interested in is clearly it sounds like you really have a very intentional architectural goal from the very get-go. But how has the core technology of Arweave maybe evolved over time, adapted to either support other use cases or just build for things that people were looking for? I'm just curious how that evolution has really changed, because you've been at it now for almost a decade, which is really incredible in and of itself.
Yeah. So I would say that the architecture of Arweave, the V1 that we shipped in 2018 allowed you to store about 10 megabytes or something per transaction, and there are 1,000 transactions per block. So 10 gig per block.
Yeah.
V2, which we built actually, productivity hack. The period of time between Christmas and New Year, nobody is doing anything. And so if you use that time to build, you get 6 straight days of uninterrupted builder time, which I know in my world is
I love that.
kind of a boon. But anyway, I was building in that period in 2019, really like the key fundamentals shipped a few months after that. And that made it so that we went from a push-based architecture. So everybody had to replicate the information as it was written into blocks, and then you didn't have to store all the blocks. It was instead stochastically chosen which block you had to have a proof from, and so on, so that we could incentivize the data set. But that still had that bandwidth cap that we weren't happy about. Arweave 2.0 made it, as I described earlier, arbitrarily scalable. And that was the last key change to the protocol. That was the point in my head, at least. It was like, okay, the machine does exactly what we wanted it to do. Then there were some changes to the mining algorithm, just making it more efficient. But actually, I think the thing about protocols is that they shouldn't change that often.
Right.
If they're changing all the time, they're not protocols, they're products. We call them protocols because they need to be static in order to actually offer their users rights. If there is still a team somewhere that can practically come along and change the purpose of the protocol. I heard someone say, is Arweave going to pivot to AI relatively recently? I found the idea hilarious because it's, look, if someone can come along and pivot the actual technology of a protocol, okay, how you apply it, there's a bunch of different things people are doing with AI on top of Arweave now. But the protocol itself shouldn't change. It should just be the Unix philosophy in a way. It should be simple, complete, and do one thing and do that one thing extremely well. And that's exactly what Arweave does. And my background, I was doing a PhD in computer science before. I care very deeply about the technology actually being right. And I'm pretty happy to say, hit by a bus now. I'd be like, okay, it's in the right spot. It'll work.
Good. That's super fascinating. And appreciate that you're thinking about protocol development needs to be something that you build, and maybe there's a fine-tuning along the way, but at the end of the day, protocol should be established just like the rest of the internet stack is, or any other protocol that we have in technology. So I guess the next evolution of what you've been working on then is AO, which is this hyper parallel compute project that you have, which maybe isn't a protocol per se, it's more of a product, or is it a...
No, it's a protocol.
Protocol. Okay, protocol.
Yeah, there's still things about it that are changing because it's just so early. But with mainnet launch that happened 2 months ago, we're pretty happily in a spot now where the core of the protocol, I don't think we'll have to change much, if at all, in the future. And you're absolutely right. There's little tweaks. With our we use, would the Bitcoin community accept this change as our own internal barometer of whether the changes that we propose are reasonable? And yeah, I think we're approaching that state with the core of AO. It's built as an extremely modular system, though. So the AO core protocol, which is called AO core, is very basic in some sense and flexible. It's exactly built like that Unix philosophy. It's intended to be maximally useful and minimally opinionated. And then you can build whatever you want on top of that. And yeah, that's just like what we've been doing with Arweave all these years too.
That's super fascinating. Can you give me a kind of a high level overview of what AO is? And obviously it's not Arweave, but maybe help understand some of the relationships between the two for people that are diving in.
Yeah, for sure. So AO, put simply, is a hyperparallel computer. It takes that same idea of people storing blockchain information inside Arweave, but then scales it so that we use the fact that there is a neutral data layer between what are essentially many blockchains. We take that to its sort of maximal conclusion, which is that, well, every single contract should be an asynchronously executing process. I'm excited to speak to you about this. It seems like you have the deep technological background, and so sometimes this is harder to explain to people, but it struck me as quite almost hilarious or depressing, depending on which way you look at it, that in the smart contract space, basically the expectation is that we should have a single thread of execution that is spread between many applications.
Right.
And this is done for a reason that doesn't even make sense.
Right.
It's you want global shared state is the idea, which is basically that every program can read and write to the memory of every other program, which kind of sounds useful at first glance. But then you realize in order to achieve that, it is necessarily true that program A must not be running while program B can execute interactions on top of its memory. And so this leads to what we've seen in the Ethereum world. And then the other architectures that exist are slight improvements on that. They still have global shared state and subsequently many processes or many contracts waiting for other interactions to finish before they're allowed to access and change the state. But maybe you can do it across like 4 threads or 8 threads like Solana. The operating system I was building during my PhD years was built using this programming language called Erlang, which was engineered in like the 80s or something. To basically run telephony applications. So the question then was, how can we make it so that we can handle 1 million calls from a single box and route them from the right sender to the right receiver? And they built this architecture called the actor model, or actor-oriented programming. And essentially the idea is that you represent the problem that you're trying to solve as a set of asynchronous processes. And instead of sharing global state, they send messages asynchronously. So I can send you a message, and then I can get on with other things. You can be doing other things while you receive that message. Then you get to it when you get to it, and you maybe send me a reply. And in both of those contexts, we're able to continue executing things at the same time. And this is the reason I find it funny or strange that this didn't develop in the smart contract ecosystem is if you ask any normal computer science, like a practitioner, that sounds like a weird word for it, but I suppose it's accurate.
Sure.
Outside of the crypto space, how are you going to build a massively scalable compute engine? The idea that it would share global state memory is absolutely nuts. No one would do that. It's completely absurd. And that wasn't actually how we got to building it. Interestingly, we acquired Odyssey, which is this partially decentralized social media application. Basically, It's a YouTube alternative. It has 7 or 8 million monthly active users. It's by far the largest active Web3 social network. And we wanted to move it to Arweave. And our theory was, and still is, that while people are generally, or a good subset of the population is excited about the idea of having real rights, you'd think people would care about that more, but at least some people do.
Sure.
Yeah, they're not well served because the network effects of the existing systems are just so vast that even if you want to move away from X, it's actually quite difficult because the audience is there. And so we were thinking about that problem, about how do you potentially offer something that's even better so that people are more incentivized to stay, and then you create this, you escape the network effects essentially. And Odyssey already has this core community that's very stable, so they bootstrap that. But how do we grow it even further? And we see the answer is, well, better monetization. So make it so that all the content that people upload, they own literally themselves with real world enforceable rights as well on on-chain rights. And then let them trade those rights and have royalties associated with it. So you have an open marketplace for content. And you have all the underpinnings to make that work with Arweave. But one thing we were missing was a compute layer. And so we looked at, I didn't really want to get into the world of building a smart contract chain because I don't particularly want to have the same conversation 10,000 times about explaining the difference between global shared state and why that's a bad idea and message passing.
Yeah.
But we looked around and just no one had a smart contracting system that was remotely scalable enough to support 8 million monthly active users, all the content that they're uploading. And then we also wanted agents to be able to buy and sell that content in a way that was going to create a liquid market for creators, because that's ultimately how you win this game. You give them something that is just like, you could go to YouTube where they own your identity, they own all your rights, and maybe they pay you. Or you could come here and you could own all that yourself and then choose to monetize it whenever and however you want. And we just started building AO, or what became AO, along that line. Have every single contract be asynchronous, send messages when you want to interact with other contracts. Don't wait, and it scales like a supercomputer. And we got the testnet built in about 4 or 5 months, and we had a launch event where we were expecting like core members of the Arweave community might check it out and find it interesting, but we'd have some time to build it out into the full experience and focus on that one main use case that we cared about. Actually, what happened was like it caught fire immensely quickly, and the growth was just crazy. There was about 2 billion messages passed in the testnet phase.
Oh my gosh.
Which was like 10 months or something.
That's staggering.
So we got to mainnet a couple of months ago, and there we go.
Wow. Excuse my naivete, but I'm interested on does each effectively smart contract have its own thread then, or is it that the logic that would dictate a smart contract, is that shared through threads? So it's one thread per kind of smart contract effectively?
One thread per smart contract. And then if you want more scalability, so say you run an on-chain order book, which there are many projects doing on top of AO now, you can just split out your application into any number of other processes as well. And it's just like we also saw that, say, Polkadot and Cosmos had something of a similar idea, and you could argue also that Ethereum by inaction to some extent, and that's not to don't want to disparage Ethereum, like what they built was incredible. It pushed the industry forward a decade in a year.
Yeah.
It was really incredible work, but they had the ossification problem. The protocol became very hard to change because there were many stakeholders when it also didn't serve its purpose. That's also why we focused on getting Arweave scalable as soon as we possibly could, so that adoption didn't outpace technology. And then you want to be in a position where you have a scale-free protocol when adoption arrives, so that everyone can just keep building on it and it just keeps growing, rather than they're building on it and it's like falling apart, and you have to make different design trade-offs which don't work for different parties in order to fix it. So Ethereum suffered from that problem. They got stuck with a single thread, and then ultimately in the end, people started building other threads as different roll-ups on top of it. And so it's like tending towards an AO-like architecture, but the difference is that, and even Vitalik now has publicly tweeted about like, why do we need global shared state anyway?
Yeah.
It's not actually that cool.
Yeah.
And the cost is immense. They're moving in that direction, but the thing is, to start a new roll-up is like $100 million endeavor. It's a huge deal. And then even then you have one more thread, but that is just shared between many different, every smart contract that's resident in it. And then to bridge between them isn't easy either. And so with AO, what we did is we said, okay, let's break it down into its core components. Like, what do you really need? You need some sort of scheduling system, so a sequencer of some form that says this came before that, so that you can't have this double spend. There's intricacies there, but broadly speaking, that's the function. Then you also have compute. And so when we were building AO, we thought, okay, what if you make it so that there are sub-networks for these different components, and then have them be open, neutral infrastructure shared between all of the processes. So you can just call your process back on any compute unit and pay the operator for telling you the state of the system. And then you can just register as a new scheduling unit in the system and start getting work scheduling different processes. And so the process of building a new roll-up like thing, if you will, adding a new thread to the network becomes, instead of this $100 million investable process, becomes, okay, you just write one line and boom, now you've spawned a new process and it just works.
Yeah. So for mine, just so I understand this, does that mean that the sequencer then keeps like a series of timestamps for the messages that that interact between the different threads? Is that like high level how it works?
Yeah, broadly speaking, it's only interested in one process, and then there are these things called messaging units that basically take outputs from one and put them into the inbox of another. So they send it or take it from a compute unit, put it into the inbox of a different process, and then the scheduler really only cares about the timestamps and the ordering of that one particular process that it's trying to serve.
Got it. And then that's distributed across the different nodes on the network, so they can. It's not necessarily maintaining state, but there's like the auditability of that there was state managed in its correct form.
Exactly. And the nice thing about it is because we have Arweave as the backbone, the basically like data transmission layer, it's like a gossip network that never forgets in some sense. So you just post data to it, and then you can see, okay, the scheduler for this process assigned slot 7 at this point in time, and then slot 8 on top of it, and you get the hash chain that builds you back to the root.
Very interesting. Speaking of the different kind of components of AO, what are maybe the different node types or different devices or people that are interested? What does participation look like within the network?
Yeah, after we built the testnet, which really had these like 3 different units that I described as concrete, they were different code bases even, and you had to be one or the other, or you had to run multiple pieces of software on your host server. Yeah, after that, we thought that's not optimal. We can do better than that. And so we ended up building what we call Hyperbeam, which is basically like a X unit, if you will. It's like an operating system for running these different, what we now call devices. A device because it's a supercomputer, and it's basically a way of plugging in a piece of code to it. And yes, there's a scheduler, there's a messaging unit, and there's a computation in many different forms, actually. And that kind of leads to the unlock here, which is that you essentially now just have an operating system for executing different types of state resolvers. And it's really arbitrary. Like it's one of those strange situations where we went to go solve this one very particular problem, which is making a version of AO which was mainnet ready, but we ended up coming out with it with something that yes does that, but also a bunch of other stuff as well. And so to execute a normal AO process under the hood, you're actually using about 30 different devices. Wow. And those can all be swapped out at will. So pretty much everything about the way that it executes, does it use a WASM environment, or does it use maybe EVM or something else? That's just a device. You can plug it, you can swap it out and plug it into the same stack of other devices, and it just runs like normal. You just have to call it Hyperbeam because that's the virtual machine underneath Erlang. Hyper because it's hyper-parallel. Yeah, you just have to find a Hyperbeam node that will run it for you. And maybe that node has a different pricing structure that it wants to enforce. It can just change out the pricing device, price estimator. And so everything becomes extremely flexible. And all of the code for that is stored on Arweave. And so you can, as a node operator, just boot a node up and say, okay, I trust these addresses as publishers of code that runs devices. And if a user comes along and they want to execute foreign computation to you that you've never seen before, your node, if you trust someone that has implemented that device, will just go and execute it for them and then charge them. And so it's like an operating system is the best analogy.
Is that how AO is able to function without this like oracles or a similar concept?
Yeah, so one of the things that it has inside the system is a relay device, which will just take your request or your message and then push it to anywhere. And it turns out that anywhere, because we use this thing called HTTP signed messages under the hood. You spoke earlier about the internet stack and its stability. We figured instead of just trying to build everything from scratch, what if we could actually build this system, this computation or location independent and verifiable computation system, which is fundamentally what a smart contract system is trying to achieve. What if we could build that into the existing protocols? And we already explored that a bit with Arweave and the integration with HTTP, basically so that all the data is available via HTTP. What if we make it so that all of the state transformations are embedded inside it? And so there's this standard internet standard rather, called HTTP signed messages, which allows you to sign any request and response from a HTTP server. And that is essentially all you need to represent transactions. And so in AO, we basically just built that in. And that means that anything on the internet or any library that supports HTTP SIG instantly is able to use AO without any custom code. And that even means that you can, take a message and send it to Binance to get a piece of content from them, like maybe a price, and then put that into an AO process. And it's just like you're using any other service in the system.
That's so interesting. If you're not a developer, it's maybe a little bit difficult to appreciate how big of an unlock that is, but that's really massive. It's to say simply.
Yeah, we're super, super excited about it. I think it's very interesting because it is an entirely different type of paradigm. The closest thing is something like take the web, but replace content with compute. And that's the closest I can say in a few words for it for someone that doesn't understand the technology. But when you speak to people with a development background, they're like, I haven't shown it to anyone yet who's not been like blown away by it and like excited about all the things they can build on top of it, which is really cool.
Yeah, so that's amazing. I do want to dig into some of the DePIN related things in terms of how all of this intersects. But one of the other questions I had when I was digging through your documentation was you use a language called Lua, if I'm not mistaken, or that's one language that people can develop their smart contracts in. Is that correct?
Exactly, yeah. So we built the system called AOS, which is like a user land operating system. And that was actually, for me personally, one of the that was when I was like blown away and excited about this new system, was when I first saw, when you get to the point where you can arbitrarily perform compute in a trustless way, the experience changes. And normally if you write a smart contract, I think it's really telling that one of the leading development environments for Ethereum smart contracts is called hard hat.
Yeah.
You're putting on a hard hat, you're going to a construction site and it's slightly dangerous and it has that vibe to it. It doesn't. Actually, when you use the system, you just boot up a terminal most of the time. Most people use AOS, don't have to. You can, people have built all sorts of stuff in like C, Rust, Go, pretty much anything you can imagine because it compiles to WASM. And even if it didn't compile to WASM, you can just replace that WASM container with a EVM device if you so desire. Yeah, but when you start building on top of the system, you just boot up a console and it feels like you've logged into a remote server, anyone in the tech side. If you SSH into a box, it feels exactly the same. It's, it's a terminal. I get it. I can write stuff, interact with the system live, and then load code and execute it, just almost like I'm writing scripts. And I try it out, and if it doesn't work, I just change it.
Yeah.
And then if you want to make it trustless and immutable, you just say owner equals nil. And then there you go. Now no one can change it, including you.
That's really exciting. I'm blown away by all of the development and just the thoughtfulness that you put into it, because you're right, there's been such maybe a misstep in terms of how a lot of these architecturally designed systems either started or the way they tried to course correct them. So this is like a ground up redesign with sort of first principles driving the design mechanism.
Yeah, that was the idea. It's funny that we just built it to solve our own problem first, and then we haven't had time to solve our own problem. There's all these other people building on top of it, which is great.
Yeah. I love that. Getting to dog food your own solution is great, even if it means that maybe you're having to push that off a little bit. But I'd love to dive into, speaking of other people developing using what you've built, I'd love to unpack how this is really going to be important for maybe DePIN projects out there, which span a ton of different verticals and have a variety of use cases. But can you maybe share some of the unique benefits that AO can really bring to DePIN projects?
Yeah, sure. Hyperbeam, that node software I was describing, really might be best described as a DePIN operating system in a way. imagine that you have something like Unix, and if you want to add a little utility, you just write like a script on top of it. The way that we see it now, having gone through the process of building this out, and it wasn't obvious to us at the start either, but now is, it's as if everything in the blockchain space so far has been building application-specific logic into the system layer, right? So you start from zero. Okay, I need a gossip network, so I got to go build that component. I need proof systems. I got to build support for a TEE, something like this. All of that is like operating system services in this new stack, if you will. It's not really application specific, but people were building it from the ground up in order to just serve this one use case. And when you're building on top of AO core, instead, what you can do is say, okay, I need this one little bit of logic, my application logic. I'll just encapsulate that into a device. And then I can use all of the other devices that cover like 99% of the things that you would otherwise have to build in an open, transparent framework. And then when it goes to deployment, so, okay, typically you had to ground up, bootstrap a network. And why was starting a roll up a $100 million affair? Was because you have to bootstrap like the economy,
right,
and the community and the node operators, if indeed your roll up is actually even operable by other people. But
yeah, sure.
Yeah, so you have to do all of this stuff yourself normally. But in AO core, you can just build a single tiny device or even a WASM container that just covers the very specific new logic that your application provides, and then lean on this existing stack of everything else. And then also all of the node operators that are running Hyperbeam nodes. If your implementation is uploaded by someone that is on their sort of trusted signers list, they will just automatically start running it. And if not, it's just a case of convincing them, hey, please offer this device to users. And then there you go. That's a DePIN network. So it's crazy powerful in that way. And you can even depend on other security systems. So one of the things that AO's done, or AO Core has done since launch a couple of months ago, is support running inside a TEE. And what that means for the people who are maybe less technically oriented in the audience is that it's a trusted execution environment. Think of something like a ledger where it stores your key in a way that is not accessible outside of a single piece of hardware, but it also does full computation, does so in a private way. There's a TEE device in AO. So if you want your DePIN network to also depend on proofs that it's running inside a secure or private environment, you literally just you call one function to validate that it's inside a TEE, and there you go. And then from a user's perspective, they can even point their browser to a result from one of those nodes. And in the headers, they will find a signature that proves that it's associated with a key that then they can also go and prove is only available inside this trusted execution environment. And you get that for free.
That's massive. That's really big. Does that mean then that the nodes are that like they actually have the secure enclave or like a trusted execution environment within their hardware device that the operating system can talk to or interact with, or is it actually at the software layer that it's like emulating the function of a trusted execution environment? This is a little bit above my pay grade, but I'm curious how that all plays together.
Yeah, so if you're running in a trusted execution environment or you're a node operator that wants to do that, there's a system called Hyperbeam OS. Everything is an operating system, unfortunately, in this context. But you can run Hyperbeam just on a normal computer, like on your Mac or on a Linux machine. Someone's also working on a PR for Windows. But you can also just run it in a container. That's Hyperbeam operating system. You boot it up and it just boots straight into the node software. And that can prove that it's running a very specific piece of software, even down to the firmware of the CPU that it's executing on. And all of that is made transparently available to people on the outside. It's cool. It's like you have a trustless, neutral box. And there's no backdoor where the person that even owns the physical hardware can change anything about it. It's completely transparent to the outside. And then you can choose, okay, if, for example, I execute this WebAssembly code inside it, and it gives me back an attestation, I can prove that was done correctly within reasonable bounds. And you can also get other nodes to execute it too and stack those signatures on top of each other. And there you go. That's like a decentralized version of AWS Lambda.
Yeah.
And it's actually just a URL that you could hit with curl on the outside.
Oh, that's so great. That's so fascinating. I know that for people that are maybe more on just the general side of it, like I said, there's maybe a bit of a translation gap, but the short synopsis is that's really impactful and going to drive the needle in terms of what's capable from a development standpoint significantly compared to what's out there today. I love that. So what else is on the team's kind of roadmap for here? Clearly, you've got your hands full with lots and lots of development work. It sounds like the core kind of operating system protocol development is quite sound, but what's next?
Yeah, so as I mentioned, there are like 30 devices on top of that core layer that are at various stages of maturity. So we have a lot of work to do building those out. And then actually, to be honest, I think it's documentation at this point. It's interesting, this is the second network that I was at least personally involved with starting. And one of the learnings from the first one was the focus should solely be tech until you have it in a position where it offers really powerfully valuable things to people. There's no point shouting about it until it is ready. Our focus has been on that, and now I think we're in the last phases of it, which is basically explaining it in documentation so that when people get curious about it, they can just go and read about it, and it's all easy to understand and learn about and then deploy things on top of. So we're at that phase, and then I think that'll be like a month or something approximately. There's a lot to document. Yeah, after that, it will really just be a case of advocating for it, explaining it to people, helping them on board. There's already people building their own devices, like a GPU network that allows you to run. You've always been able to, at least since last June, run LLMs inside these smart contracts in AO, wow, but using only the CPU. So you get about like 1 token per second, something like this. Yeah, someone built a GPU device that you can just plug into your Hyperbeam node, and then anyone can write code that can call upon it. You call it back on the right Hyperbeam node or one with a GPU, and it will just go execute for you super fast. So a ton of working with teams like that to make use of the technology, essentially.
That's really interesting. There's so much that's happening. I'm just really fascinated and impressed at how much you guys have been able to accomplish as a team, given how many intricacies there are for what you've built. Gosh, we've chatted about so many different things throughout the history of Arweave, what you're building at AO. Was there anything that we didn't get a chance to cover, though, that you think's relevant or important for people to maybe be aware of?
I guess there's the fair launch mechanism of AO as well. It's just like Bitcoin in that it's 100% fair launch. There's no pre-sale, nothing like this. Yeah, and you can just, instead of distributing the tokens to provide provision of security, we just distribute the tokens to users for using it. And you do that basically by placing your economic residency inside AO, which is just like bridging assets into it, and then you earn ownership of the protocol proportionally to it. Yeah, which I think is pretty cool, and it's very early phase. Follows Bitcoin's 21 million tokens model and halves every 4 years as well. So it's pretty slow release. Yeah, and we're like 15% of the way through the token supply or something right now.
Okay. Wow. How long will that distribution process happen for?
Just like Bitcoin, it goes on arbitrarily long, but...
Does it ever end? Well, like Bitcoin ends at 140 years or something like that?
Yeah, in this case, no, it doesn't. It actually, or I guess it technically does so we took the Bitcoin emission curve, and one thing that we thought was like a fundamental problem with it, we wanted to keep everything as Bitcoin as we could, but the halvings create shocks for the market. And it'd be far better if that's smooth. And the math to do it is actually quite simple. It's not as simple as, I don't know if you've read in the Bitcoin code where they do that, they literally just bit shift, which is, can't get more simple than this. But we probably shouldn't be making economic policy based on bit shifting.
Yes.
So instead, it's exactly like Bitcoin having a 4-year halving, but it just does so very smoothly. It's technically more like a half-life than a halving.
Okay, interesting. That's really good to know. Gosh, there's so much thought that has been put into this, which is really fascinating, both from just a technical standpoint, but also from how this impacts people that are going to be using it. Because at the end of the day, that's what you're building the technology for. And I appreciate the level of thoughtfulness that has gone into this. Sam, we have talked about so much. I really appreciate you coming on. Where should people go check out AO, Arweave, yourself? Where's the best place for them to stay updated?
The permweb, of course.
Of course.
So if you want to learn about AO, it's just actually any Arweave gateway, but arweave.net or ar.io. There's 300 to pick from. And for Arweave, Arweave. Same. And for me, sam.arweave.net has all my links, and it's my personal homepage on the permweb. So
Perfect. We will definitely have all that link below. So certainly go check out everything that Sam and his team is working on. Sam, I want to say thank you so much again for coming on to get a chance to chat. This has been really fun. I've enjoyed geeking out with you a little bit about all the work that's gone into these projects.
Yeah, thank you very much. It's fun to chat about like the deep tech behind this stuff.
Yeah,
Appreciate it.
It gets me really excited. Awesome. We want to thank everybody so much for tuning in. This has been a really fascinating conversation. Certainly go check out Sam, go check out AO, go check out Arweave. We'll have all that linked below so it's easy to find. But we want to thank you again, and we will see everyone on the next one. Take care.